try this out. You can use the chat button too at the bottom to chat if you have a question. This blinks at me down here if someone ends up having a question, or you can just say something if you start to have a question. So I'm going to go ahead and hit share, and we're going to look at a presentation that I set up for today that will be how to do the rest of the floor framing stuff that we had planned to do before all of this happened. So this was where we were at. I think before we left for break, we talked about how to determine floor framing sizes for the same size foundation plan that I have here. This is the 20 feet by 28 foot foundation. And what I want you to imagine is that we have the lally columns spaced at every 7 feet apart. And so with that information, based on this design criteria, we're going to figure out how to select a built-up beam size, because that's, I think, where we left off in the last class. We hadn't actually done that yet. So these are the 3 things you need to know. You need to know the building width, because the building width determines how much weight that beam in the middle is holding up. As this building width gets wider, the beam holds up more weight because it holds up half of this span on this side and half of this span on the other side. So this beam here we're going to design will actually hold up 10 feet of the 20-foot wide building. The next thing you need to know is the span. And the span is not the full length that the beam spans, but the distance the beam spans unsupported. So that would be the 7 feet from lally column to the wall or between lally columns. If one of these numbers was 8 feet and the rest were 7, then we would be using the 8-foot span, because you're going to always use the worst case scenario. And then the last thing you need to know is how many floors do you have? So we're going to pretend that this is a 1-floor structure. Now this is your table that you're going to use for the girder spans and header spans, and you can get this if you go into that Google Drive link. You're in your lesson plan. You can get those floor framing resources here by clicking on that and seeing it, or you can go to your Google Drive. You go to your Google Drive by going here, click on Drive, and I've made you all have access, I believe, to this folder called, let's see here, SMCC class resource folders, student R drive resources, and AEDD 165. So you should have access to this AEDD 165. And where I am, this is similar to the layout that we had in the R drive at school. And under handouts and lesson plans, we're in the floor framing too, where we have span tables. And you would probably recognize this span table from the handouts I gave you before we left this semester. Speak up if you have not seen this before. Okay, good. All right, so this span table we didn't get a chance to talk about. So this is going to be how we would determine our beam sizes, a built-up beam size for nominal wood. So the first thing we want to consider is what kind of beam this is. So this is only supporting a roof and ceiling. This is supporting a roof, ceiling, and 1 center bearing floor. This is supporting a roof, ceiling, and a clear span floor, which means the beam is on either the left or the right side of the entire span. And this is center bearing with 2 stories and then clear span with 2 stories. So our scenario with this problem is our roof, ceiling, and 1 center bearing floor. So if I go back to my, hide this. If I go back to that floor framing slide, this is that page, and I'm highlighting this area and the 20 feet because that's the width of our building, and this is the area that we want to be looking at. In the next slide, we zoom in on that and we see sorry, I skipped 2 slides. We see that the one scenario that would work, or there's a few, but this one would work and be the smallest beam that we could design, would be 2 2x12s, because our lally column spacing is at 7 feet, which is below the 7'4" that's shown here. So this would work for our beam design for this particular scenario. Does anybody have any questions so far? Is this making sense? Okay. The next thing that we would do too, this is what we did before class, as we went through and we found, you know, what size floor joists work with the span we're working in. And so this is just a refresher. The spruce pine fir number 2. This bar, if you will, is what I'm going to look at, and I'm looking for numbers that match 10 feet or higher to use. So I'm going to use spruce pine fir number 2, 2x10s at 24 inches on center, because it achieves here 11'6". It achieves a 40 live load and a 20 dead load, and I have a plenty of room, a max span of 11'6". I've got an additional 1 foot 6 inches to play with. So the next step would be to add that framing notes to the slide, to your plans rather. So these framing notes, this is the framing notes here. I've added very simple ones. These are going to be 2x10s at 24 inches on center, and this is going to be a 2 2x12 beam. And then this view here, whoops, I went way too. Let's go back. This beam here, or detail here, shows a sketch of what would the sill look like with that scenario and the kinds of callouts that we'd see. 2x10s at 24 inches on center is the floor framing. We'd be using 2x10 joist hangers. And then there's our beam, 2 2x12 beams resting on top of our lally column. And that little piece right there is our lally column plate. So finally, when we look at this in a CAD or more formal format, this would be what our floor framing might look like on a finished foundation plan. And in this scenario, we've added the lines to indicate the actual floor joist spacing. It's not necessary though. It's fine just to write in what your span and your joist sizes are. And then in the places where we have openings, you can see we've doubled up or tripled up our floor joist. So this is that beam. It's actually just being drawn with the actual thickness of the beam shown in this plan. But you can be as simple as this as well though, just to show your framing. Okay, so what I'm looking for you to do is, this is one of the solutions you have to adding framing information to that foundation plan that you all worked on with the section view down below it. I want you to add framing information to that. And so this is one of those solutions that you can use. The second half of this lecture will be on engineered lumber, which we'll enter into once I've made sure that you all understand this process first. So does anybody have any questions about that procedure? How we go about starting with a design, picking a beam size, and then making sure we have the floor framing size, joist size selected properly, and then indicating that on a floor plan and in a detail view to show our framing information. And even if it's not a question, if you have a comment or you'd like to offer something, I'd love to hear it.
I just tried chatting, but what about offsetting spans when you don't have it centered and you still have some that are going to be long, some that are going to be shorter distance, anything of that note?
Yes, okay, that's a good question. So an offset span, let's imagine we had instead here of putting this right in the center of our 20-foot wide building. What if we made one side 8 feet, for instance, and the other side 12? How would we make changes to our floor framing. Let me ask you all a question. Do you think the beam size would change because of that?
You'd probably make it for the longer span and then equalize that for the other, so it would be the same across the board, or would you make them different sizes?
The floor joist, yes, but do you see that the beam size would not change? Because the beam size is not being affected because the width of the building didn't change, the number of
Right.
stories didn't change, right? And our lally column spacing did not change. But because we've offset, if we push this down to 8 feet here on this side and 12 on the other, what would change would be we might go up to a 2x12s at 24 inches on center to have 13 foot 4 inches instead of 11 foot 6, so that that number exceeds our design of 12 feet in that scenario. So our worst case scenario in that would be that that one of these sides would be 12 feet. I wouldn't care about the other side of 8 feet. I want to design the floor framing so it would work with the 12-foot side, correct? And then I'd
And
know it is going to work for both.
you'd be consistent for even the shorter spans?
If
So,
you were inconsistent, you end up with a situation where, and I guess I can use AutoCAD to show you that in a moment, but you'd end up with a situation that one side of your floor joists, let me go back to the view where we have the detailing. So if I decided to use 8 foot, let's say I used a 2x10s at 24 inches on center on this side, or 2x12s at 24 rather, and then on this side I went down to 2x8s at 24 inches on center. Can you imagine what's going to happen here on the other side of that sill? We're going to end up with a 2x8 that doesn't touch the mud sill, so you're going to end up having to shim that 2x8 up on the other side. So it's usually a better idea to leave the floor framing the same depth and maybe change spacing at the most. But if you do change the depth of the floor framing on one side to the other, you've got to take into account how you're going to deal with carrying that difference in height here, because this rim is going to stay the same size all the way around the building. That has to stay the same size. So on the other side, where this side is 2x8s, we're going to have to put some blocking underneath that to hold it up. That's all you have to consider. Okay? So just offset spans, you usually want to design to the worst case scenario. Any other questions like that one?
So I'm looking at where my drawing was at, and I had not spaced the lally columns out evenly. I had like 8.5 feet from the wall to the first one on each side, and then 5.5 feet between the middle ones. Does that affect what kind of beam I would do down the middle?
Yes. So what you would do is go back to that span chart. Let me make sure I get the span chart open here, wherever that is. I think, yeah, there it is. And so our building width for the Josephine is 28 feet, I think. So you would go under 28 feet, you look at 28 feet, and we are supporting a roof, ceiling, and one center bearing floor, just like we are in this scenario. But you said your lally columns, the widest they're spaced is 8 feet 5 inches.
8 foot
So you
6.
8 foot 6. So you'd have to use. Do you see how my cursor is going right across where I've got the first number that I come to that exceeds your 8 foot 6 span is the 9 foot 3. And when we go across, that means you need 4 2x12s.
Right. Okay.
Okay. So if you decide to change the spacing between those lally columns, and you push them, you push the ones that are a lot closer together apart so that you reduce that to 8 feet or less, then you have some other choices then. Do you see that? Okay. Yeah, that's a good question too. So your lally column spacing, if it doesn't happen to be the same throughout your floor plan, whoops, sorry, oh geez, I lost track of where it was. There we go. It's not the same all the way across. You want to find whatever distance that your lally columns are spaced the furthest apart is the number you're going to use here. okay? So could we get away, let me ask a question to see if this makes sense to everybody. If I decided to take away a lally column, I would have 28 feet divided by 3, which would be 9 feet 4 inches, okay? So I'd end up with 9 feet 4 inches. I could use 4 2x12s and get away with removing a lally column if I did that. Does that make sense to everyone? Because I can span up to 10 feet 7 inches. So that means these lally columns could be up to 10 feet 7 inches apart. And so I could remove one of these lally columns, but it means my beam has to go up quite a bit.
Which is the more cost-effective measure there? A lally column or extra 2x12?
Well, it's less about cost effective than it is about how this space is going to be used. Lally columns can really be pesky things. I had, my grandmother had a what do you call it, a billiards table in the basement, and one of those lally columns was always in the way. I wish she had fewer lally columns. But if you're just using your basement for utility space and some limited storage, then it probably doesn't matter. And building more lally columns in here and using a smaller beam might be might make more sense. If you're wanting this space to be more of a functional space, maybe you want fewer lally columns. So the cost part of it is less about it than the what the desired space function wants to be, if that makes sense. Okay. So that's how you play with these numbers. These second numbers that show up here are only applied when we're designing headers over windows and doors. This stands for the number of jack studs that we have next to our window and doors. So notice with the larger openings, we have to have 2 jack studs on either side of our openings to achieve that width of an opening. So this doesn't come into play, in other words, with our girder design that we're doing here. Okay. All right, so how does everybody feel about that? If you needed to go back to the Josephine and design a floor framing plan for using nominal wood, do you think you could do it?
Yeah.
Everybody feels good with that? All right, so you want to press on, we'll go right into engineered wood. So this is what we're going to do, is look at engineered wood. It's a little bit different animal. What's missing from this picture is there are no more lally columns. And that's because with engineered I-joists, we can probably get rid of the lally columns and span the clear distance because they can span much longer distances. So we're not designing a beam here, we're going to design a floor system. What's the information we need to know for plucking out that information for engineered wood is we need to know the building width still. We need to know the maximum span, which happens to be the building width, and we still need to know the number of stories, because that gives us some idea of our building load. So now we're going to be looking at, this is a excerpt from this reference, engineered lumber. TJI 4000 PDF is a document that just has the specifications on these types of I-joists. And an I-joist is an engineered floor framing member with flange and web. And these dimensions here are critical for you as designers, because if somebody specifies or you're specifying I-joist floor framing, you need to be able to show it correctly in section. And you need to also be able to show what it would look like from the side view. So you need to know what these dimensions would be. These sizes that you see below are the different nominal sizes for each one of these I-joist types, and they usually result in the size of the web or the flange being wider or thicker in order to span longer distances. So this is going to be the thickest web and the widest flange here on the end, these TJI 560 joists, and they come in these depths. 16 inches is the deepest floor joist. 16-inch floor joist depth is pretty deep. But and so that's a whole other ball of wax. When you start to design your full building section, you have to take into consideration that's a huge amount of plenum space that is being taken up by your floor plate, 16 inches. So down a little bit further than that, so that's critical information for you all. Down a little bit further than that, these are our span tables. And because you've not learned a little bit about nominal wood span tables, you can probably figure out how to read these. Because once you understand this stuff, all you need to get is manufacturer specifications on a lot of these things, and you can figure out what that particular framing member is capable of. So we're using the minimum code criteria here of L over 360. That's our deflection. And we have very similar numbers that we see here: 40-pound live load, 10-pound dead load, 40-pound live load, 20-pound dead load. And our depths for our floor joists are based off of the I-joist system instead of our nominal wood. And then inside of those depths, we have the different sizes that we have available for that particular depth. Pardon me. So if we wanted to design a floor framing plan that would work for our 20-foot by 28-foot structure, we're looking for numbers here that are 20 feet or higher, and then we can figure out what size that is. So I'm going to go back to my it keeps getting in my way. Let me go back to that floor framing so you can see what that looks like.
Could we also find this in our textbook as well?
This stuff isn't in your textbook because this is manufacturer specification stuff. I actually pulled this from a manufacturer spec. Your textbook does have some information on maximum spans for different materials, but it's very generic. Like it will say, for instance, what's the a span range for floor trusses, and span ranges for nominal wood, and span ranges for steel and stuff like that, but it won't tell you specifically what's the span, what's the exact span this can do at this size, blah, blah, blah. That's manufacturer's specifications, or the Wood Council has to tell you that. Those are those span charts that we're using, okay?
Okay.
And I'm just using one example. This is a particular truss manufacturer, but if you were to go online and Google I-joist truss systems, there's a bunch of different companies that make these, and you can probably download PDFs that indicate what those are. I'd like us all to use this one though, so that we can compare apples to apples. But going forward, once you understand this, if you would like to spec out floor system for your project that's from a particular manufacturer, as long as you make sure you're providing the particular manufacturer span chart information, you can do that, okay? So what this is showing you is I've highlighted in red which ones meet the requirement. Now my criteria I'm sticking to is I want to try to make the depth as small as possible. I'm trying to avoid the 14 and the 16-inch depths. So these are the closest to what we would have for nominal sizes that we can get. And the other thing I'm avoiding is any of the numbers that are in italics. So the numbers that are in italics, if I go back to the original document here, the italicized numbers, bold italic spans, reflect initial dead load deflection exceeding 0.33 inches. So remember what deflection is. It identifies how much of a bow will happen in your floor. So that means that the center of the floor with the weight loaded on it is going to be 0.3 inches lower than the edge of the floor where it's connected to the wall, or greater. So if you were to take a marble and start it at the edge of the wall and see what would happen to it, it would roll to the center of the floor with a deflection of higher than 0.5 inches. Does that make sense? Hopefully. So I'm avoiding those italicized numbers to try to avoid that higher deflection. So that is resulting in these 1, 2, 3, 4, 5 solutions that would work. 2 of those solutions also meet the criteria of 40 live load and 20 dead load, which I think makes one of these 2 ideal for a stiffer floor. So at this point with the I-joist framing, does anybody have any questions about how to call out an I-joist size and how to select an I-joist spacing and size based on span?
When are we choosing the engineered wood over nominal lumber if there's not a concern of like you need to go a certain distance? Would you ever do this with lolly columns, or like are you basically it's more expensive, I'm assuming, so therefore
It is. So what you're trying to do here is, if you're going to go with I-joist, the benefit in this case is that we would have a clear span and a clear basement with nothing in its way. The other benefit would be, well, actually, that's it. That's about it. The cost might be a wash because I'm going, although did we have 24-inch on center spacing for our spacing before as well? I think we did 24 inches. So the cost is going to be more expensive, exactly, because every I-joist, one I-joist costs a lot more than just one floor joist. So a lot of times this choice is you go with this choice if you can reduce the number of joists you need to do to get the same job done. But more often than not, it's because people want those clear spaces without lally columns and without bearing walls or whatever. So that's why that choice is usually made. This house is small enough that you could get away with that, and it would do nicely. So because of that question, though, I wanted to just show you another scenario. What if we wanted to just greatly reduce the number of lally columns we have? So let's put a lally column right in the middle. So we have a span of 14 feet on one side and 14 feet on the other that our beam would have to span. So we're going to use a micro lam beam to hold up the floor framing here in the middle. Since we only have one lally column, we can get away with that with a micro lam beam. And then we'll stick with floor joists. So our building width is 20 feet. Our maximum span is 14 feet for our beam here in this case. Let me just change this to, set that back to 100%, and I want to edit this. So this is picking out our micro lam beam, engineered, okay. So if we go to the next step and assume that we're going to be putting the beam there in the future, I could go down to 9.5 inch depth 110s, and those can still span 14 feet, which is well over an actual 4 feet beyond what we actually need. So to answer your question, Josh, in this case, it might be more money you're throwing at it than you need to, because it's super exceeding what it needs to do for actual floor framing. But if we were to carry on with this process, then the other thing we're going to look at is how do we determine our micro lam beam size? And that is done through a different manufacturer spec, the micro lam PDF.
Is microlam a brand name, or it's
Yes.
a type of?
Yeah, so it's a glue laminated beam is what it is. LVL or microlam, paralam are all different types or names of these types of engineered glue laminated beam structures. And you see they look different than the I-joist. This is an example of an I-joist framing into one of those microlam beams. This is just flat, doesn't have, it's a solid piece that's been built up by glue laminating layers and layers of wood together like they're showing here. And so it's very strong. And this particular PDF, you have to look through and see the different sizing tables that they're offering. So this one is showing you how to size a header over a garage door or something that's only holding up a roof. This one is showing you how to size a beam if you have a post and beam construction and you're holding up the roof rafters for SIPS panels or something like that for your roof system. This is particularly showing you how to spec out the size of a header over a rough opening on the side of a wall here. So that's not this beam here. It's the one here on the side that's highlighted in purple. So that's header supporting floor and roof. And then this last one is the one that we're going to look at. This is sizing this beam here in the middle. How big does that beam have to be to hold up this floor system? Now this engineered wood weighs more, so notice that we have a 30-pound dead load instead of a 10. We're going to use that. And we still are working with a 20-foot wide building. And when we go across, our two choices are 3.5 inch by 14 inch deep, or 5 1/4 inch by 11 and 7/8, or I think it says 7/8 inches deep. So there are our two choices right there. I've circled or highlighted that we get under that particular floor girder beam chart that we would look at. So our beam would be one of these two sizes. The 14 inch could be problematic because it could really take up a lot of space headroom wise in your basement. So that's why those two sizes vary so much in depth. Notice how much more width has to be given to that to make that strong enough to do just about the same thing. So the last slide I have for you is how would your sill detail change? So remember this detail we had that was the sketch way before. This is what your sill detail looked like before. This is the side view of that nominal wood, just 2x10. It's flat, doesn't have any flanges or webs or anything like that, so it looks very plain. But when we look at engineered wood from the side, especially an I-joist system, this is the cross-section view, so we would see from the side the top and bottom flange. This is the web in the middle, and then on the edge we don't have rim joists, we have a rim board system. And a lot of this stuff you can see by investigating a little bit more into the TJI 4000 documentation. If we scroll down to the area that shows silent floor joists framing systems, it shows you how these things get put together and framed and what we might be looking at. So this is an example here of web stiffeners that would show up in between, filling in that web area to make it even stronger in certain areas. And I think they're doing that here because they're cantilevering a little part of the floor here. It shows you what kinds of cuts can happen in that floor framing system, and it shows you some connections and joints that you'd see, the typical ones. If you scroll a little further through the document, you'll see what are the acceptable cuts that are allowed in a floor joist system like this, and then where you're not allowed to cut, because that would compromise the floor joists. And this is obvious where a structural element is. We shouldn't have anything that's near that to make sure that we keep up the structural integrity of that floor framing where it's being supported by that wall system. So I encourage you to go through and take a look at the rest of the documentation here, but what I really want you to be able to do is pick out a floor system either using engineered or nominal wood framing and add that information to your foundation projects that you've already started before the spring break.
Those were the sections you wanted to add to that section detail, or that same scale, or do you want to use these separate different scales?
So that I didn't quite hear everything. Let me hit stop sharing and maybe that'll improve some things. So I didn't quite hear that fully.
We did that section detail for our foundation plan. Some of it was tabs, did it by hand.
Oh, okay, I heard you. So you're doing I'm just getting a lot of mic reverb on yours. So yeah, so what I'm okay with going forward is I think most of you, if not all of you, started that foundation plan and have the cross section already drawn. You can go back to that plan and you can oh yeah, you've got a note here from Tori, Josh, about I think your mic is picking up your, you got to turn down your mic a little bit, maybe. That's why I couldn't hear you very well. But what you can do is add that information to those existing plans. And since I already saw those, I don't mind seeing either a scan or a picture of that. Try to take a picture as well as you can so that I can read it and see that detailing that's been added to it. I think what I'm going to do is make a quick video that shows you how to do a drawing that includes a bar scale so that you can show me that you're actually drawing things to scale in that drawing. So I can include that in the lesson notes, if you will, for this week. But I think, doesn't everybody have the foundation plan and the full section done already, correct?
Are you talking about the Josephine house or
Yes.
the?
Yep, the one that we did that was on the big sheet of paper. Some of you were doing it in AutoCAD, some of you were doing it by hand.
Right, and we were putting the foundation, we were drawing the foundation even though the like floor plan had already been printed, it was on the page already.
Right, but none of the floor plan framing is on that
Right.
page at all. So
Okay.
what I'm asking you to do is just add
I'm
the
still
framing
working on
notes to
that.
the plan. Who's that? Is that
That's me, David.
David? Okay, you're still working on that. Okay,
I have it though out in front of me,
okay.
like on my desk.
Well, what I would like you to do, David, is continue to work on it. And when you get to the point where you would like me to look at it, you can take a picture of it or
I can scan it
yep,
if you want. And
that would be great. And then that's
Yeah.
probably going to be the way we'll have to deal with those until we get to the other pieces of the puzzle. And I've reformatted this project so that everything is on an A size format now. But nobody's going to, I don't want anybody to redo the foundation in A size format. So
okay.
I'm considering the foundation as being just about done because everyone did that part of it. We're going to just add the framing information to it, and then we'll move on to the other pieces to the puzzle that will be included in the rest of the plan.
Mm-hmm.
Okay?
Mm-hmm.
So this is my effort to kind of wrap up that foundation plan by giving you this last piece, which is the framing information.
Oh, okay.
Okay? So I also want to make sure everybody understands how to read these framing charts and can pull the information out. So if you look at your updated lesson plan, here's some of the questions that I had for you to be able to fill out on the class portal. So let's take a look at the first one together. I'll give it to you, okay? We'll work together and we'll see if we can come up with the answer for it. So it's demonstrating an understanding of I-joist span charts by selecting an I-joist size for a 26-foot clear span. That means there is no lally columns, there's no beam structure, okay? So this is giving you your width right there. Doesn't matter what the length is right now because all you're doing is coming up with what size floor joist could I get to span 26 feet. And then I just wanted to make sure you were writing the I-joist size down correctly. So I've got an answer that you can provide in 40 live load and 10 dead load, and then 40 live load and 20 dead load. So let's go to the span chart and see if we can come up with some answers for that. Whoops. So I want you to look in the L over 360. You can use the same one we've been using. I'm going to zoom right in on it. And I'm going to give you all a moment. We're looking for 26 feet this time. And I want to see if we can see a solution at all in the 9.5-inch depth. Just take a moment and look at everything here in this area. And you see nothing says 26 feet, right?
Nope.
Nope. So we know we can't do 9.5. Eliminate it. Now let's look in 11 and 7/8 inch depth. What we're looking for is a number of 26 or higher. First one we come to is right here, 26 feet 3 inches. And it would be a TJI 560, 11 and 7/8 at 16 inches on center. Does that make sense?
Mm-hmm. Yep.
Okay, so that would be one of our answers, as that's a 40-pound live load and a 10-pound dead load. So if we go to our answers, we could write down, this is the I-joist size, 560, 11 and 7/8. What's the joist spacing? 16 inches on center. And what is the maximum allowable span? It's 26 feet, 3 inches. Okay? So this is, think of this, because I printed mine. I printed my whole thing out so I could actually write down stuff right on this instead of having to type it in. But if those of you like to use electronically, you should have you can save your own copy of this, because you'll notice you can't edit this document. You shouldn't be able to anyway. So if you wanted to be able to type in your answers here or keep track of them, you can save this in your own Google Drive folder and start keeping track of these answers and putting them into this document. But I also have, this is kind of my way of doing, what's it called, attendance, if you will, because I got to kind of make sure people are still checking in with this class. I've set up in your class portal, which you all are all familiar with getting to, right? 165 folder, under coursework, I have added floor framing questions right there. So if you click on your floor framing questions worksheet, whoops, it's still open, sorry. You see, I've got to go to student view, so it shows up in student view. There we go. There we go, floor framing questions. You can start the questions. I have this, you are allowed to retake this as many times as you want to until the due date. Okay, so don't freak out about getting this right or wrong or whatever. Just attempt to, whatever you put in for answers here, you're gonna type in your answers right here in an essay format and submit your answers. So you have the same 2 questions. Demonstrate your understanding of I-joist. So once you've gathered your answers and written them down first on your document, that's what I would suggest you do. Then type them in here and type them in here and fill in the answers, and then hit submit your worksheet. And you submit your worksheet, that tells me that you did your homework for this week. I will check it and give you comments and let you know if your answers are right. There is more than one right answer, which is why they're in essay format. That's how we're going to proceed, and unless it doesn't work, and then I will try a different way, but I think it's going to work by doing that. So every week you're going to have a little quiz like that to have to answer a question based off the lecture information, and that will just help me to know that you all are following along and you understand the process. Okay? So before I go, do we have any questions about any of the other problems that are on that sheet? So these are the things I'm hoping you're going to be able to answer for this week.
Where can I find that reference sheet on like the different floor spans? I mean the different joist spans and stuff.
So if you have this document live, this is one way to do it. If you go to floor framing resources,
Oh, okay. Yep.
that's one way to get there, because it's gonna, if you go there to that folder, it's gonna
Yep.
jump to that folder, and it's gonna have all the same stuff that I've been looking at over here. And because I'm opening all this stuff, that's how I'm showing you all. I'm opening the span tables and showing you the engineered lumber. There they are. Okay, so you have everything. I've tried to think of, the links that were going to be the most useful to you to have, and so they're here. Okay.
Do we have a due date on having the section details for our framing for the project?
Yes. So the due date is at the bottom. You'll see that because that's part of the final project, the due date is to submit those drawings by no later than May 7th. If you want feedback, however, anytime you want to upload something and give me something to look at, I've created in collaboration, I think I already did it, final project questions and uploads for review that you can put in there. And the reason I wanted to do it here in this discussion format is so everybody can benefit from questions or reviews that I do. Okay? And then this is another place for you to ask specifically about lecture questions. So if you do ask a question about a lecture that you maybe didn't watch live, so you couldn't ask your question, just make sure when you go in and you post your topic that you indicate which lecture it came from.
And you want everything on A-size paper?
I did reformat everything at the bottom is now an A size, because that way people can print if they're doing it by hand. If you are doing this electronically, it doesn't matter. But if you're doing it by hand, it's probably going to be a lot easier for you to use A size, because most people have a printer at home that is capable of printing A size sheets, correct?
Yeah.
So that's why. So does anybody have any other questions about these two problems? You can also post questions to each other on those formats too, and collaborate with each other. So this one we didn't do together, but I would like to see if you can figure this one out on your own. This one is the one that you're going to actually use that microlam chart that specifically talks about or covers how to size a header over an opening. So it would be this one. That's that question is asking that. So given an opening that's 10 feet, design the header for that opening that will support the floor and roof based on the loads shown in the table below. So these are your loads you're going to work with. So it's just two answers here. One for the 15 dead load and one for the 12 dead load, and 50-pound live load and 40-pound live load. Actually, that's one answer. Sorry, that's one answer, because this is your roof load and that's your floor load. I'm assuming everybody's just kind of reading a little bit and seeing what else is there. I'll stay here for a little bit longer to see if there are any more questions.
For this problem, this is for this week, and you assume like these will be due at the end of the week or by?
Yes. So what do I have set up in my coursework here? Let me go back to regular review. So those the weekly lecture questions basically that I've posted that will go along with the lecture notes. This one is due Saturday, the 28th at 5 p.m. So it gives you the whole week to answer those questions. And then when I do the wall section lecture, you have questions to answer about that one by the end of that week. Stairs and roof questions.
And we'll be putting the updates on our own finished project while those are happening as well.
Exactly. So you're this is all tools you need to complete that final project, so that you're ending up being able to draw these things. So you'll notice that some of the weeks you're actually sketching an elevation, but the reason you're sketching a wall section rather, the reason I have you answering those questions is you need those questions to be able to draw that wall section with some idea of what the wall height's going to be and the plate depth is going to be. And then we end up doing a cornice detail for what's happening at the roof, because we've done the foundation, so we're just the roof, and then we'll talk a little bit about thermal and moisture protection. But these are the items that are going to be included in that final project. And everything that we're doing is working towards that.
At this time, we can start putting it into Revit.
Absolutely. So all the stuff that you need to begin the projects, to begin the drafting part of the projects, are all located in the folders that I have here, which are called Files for Drawing. If you're doing this by hand, you want to download the PDF files in here and print them. So you have your first floor plan, and it's already been formatted to an A-size sheet of paper. It's really tight, but we can get it to fit. So because if you print this at a scale of 1:1, making sure it's at a custom full 100% zoom, in other words, you're not scaling it to fit on your sheet, then when you print this out on your plotter or printer at home, it should print out at 1/4 inch equals a foot. So you could actually draw on this to scale and add your house layout here. And I have criteria. That's why I gave you the whole lesson plan for the rest of the week, rest of the semester ahead of time. So if you wanted to go ahead and do things, you can. If you're doing this project in AutoCAD, there's all the AutoCAD files that you need right there. There's all the elevations and the first floor drawing file. If you decide you want to do this in Revit, then there's your Josephine final project in Revit that is basically just the exterior information. It has the exterior walls and the roof and the foundation already in place, but you have to lay out the floor plan, just like the CAD people and the hand drawing people would do. And you're placing your windows. Somebody's talking, but I can't hear you. All right, well, if anybody have any other questions? If you do, and if you feel like you've got it and you understand what you're doing this week, you can go ahead and sign off. If you have a follow-up question and would like to stick around and ask me, then I have until at least just about 3 o'clock today to be able to answer any other questions. Okay, I'm seeing a few people sign off. Oh, I got another chat question here. Okay. Katie, okay. You're welcome.
Hey Meredith,
Yes.
is there a way to access the S drive from my house?
Okay, good. I'm glad you asked that, because I wanted to let you know that anybody who has S drive files that they want access to, email me and ask me, or actually email Dan directly, because he's the one that has the ability with his virtual private network at home to grab your S drives and make a copy of them for you on the Google Drive and give you access.
Okay, sounds good. I'll email him.
Yep, that's perfect. Yep.
All right, thank you.
Okay.
Bye.
Bye.